So my name is Oege, for those wondering how to pronounce it, and I'm joined here by my colleague Aili. So we're both like data scientists, machine learning engineers. So we've been working mainly with data science, machine learning models. Okay, so yeah, so for the last year and a half, we've been working like many others, sadly, with LLMs and Gen AIs, and we've been working on various projects, like facing actual real customers in production, where one of the things we learned, like during all that work, is how important it is to evaluate your LLMs correctly.
So hi from me as well. I'm Aili. I've been a data scientist for several years now, and I find it a slightly ironic to be talking about LLM evaluation here, because data scientists are usually known as bad testers. But we want to bring in another perspective into the whole LLM system development that's very familiar to data scientists and ML people, which is evaluation rather than just testing.
Right, so this is kind of what we hope to convince you of today. So that if you're working on an AI application, especially something that's supposed to go into production, facing real customers, either external or internal, you absolutely need evaluations. And in fact, you should not launch without them. So this is a bit funny when you think about, like with data science, this is never an issue, because for data science, in order to do that, you need data, labeled data, which then you typically, like 80% you use for training your model, and 20% of your data you only use for evaluation. So when you work on a machine learning model, you always have an evaluation data set. It's only now with LLMs, when your model is hiding behind an API, you don't need any data. You can just like take some user input, forward it to the API endpoint of OpenAI, get a response back, give it back to the user, and you don't know whether it was a good response or not. So this whole problem is in some ways new, and it comes from the fact that like it's now so it has been made so simple and convenient to kind of build the application, build a demo very, very quickly, because everything is done by OpenAI behind a nice API. That you can launch without ever having an evaluation data set to begin with. But then the reason, like, why should you have an evaluation set or build your own nevertheless, even though you are able to launch, you don't need it to launch, you can launch without an evaluation data set, very easy, because you just forward all the inputs to OpenAI and you get the response back, send it to the user, but then like these kind of things happen. So most of you have maybe seen this, at various points in the media. So it's very famously in the US, like some car dealership in the US, like made a chatbot, basically a wrapper for a GPT 3.5 with some instruction like, you are a car dealer, a salesman, and I'll go, here's some inputs from the customer, and go talk to them. And the customers quickly found out that, this has been like this chatbot is a car dealer, or has instructions to be a car dealer. You can negotiate with this chatbot, and actually negotiate the price down all the way to $1 in some cases. And this is not just funny, because like what for the other example was like with an airline that actually also had like this chatbot that kind of gave bad advice and kind of made up flights that didn't exist or other connections. And people actually missed their flights and missed their connection or booked the wrong flight. And then they were actually held, and the people who were supposed to be on the flight actually went to court and they won. So you are responsible for what your chatbot says. You can't just say, I just forwarded something to OpenAI and they send me something back. It's not my responsibility. No, you're responsible for what your chatbot says. And the final example is from McDonald's, which earlier this year actually had an AI assistant, which they had to take offline because it started making really weird recipes with a bacon-topped ice cream, which to me sounds delicious, but apparently this was seen as a problem. So yeah, as Oege said, it's really easy to get started, to get something running and in front of your customers. But making it reliable is the difficult part here. So traditionally, when you're developing software, you know what your software does, or at least you can look at the code and you know what it can understand what it does. Here, that's not the case. So you have this very scary, maybe not always so scary parrot churning out something, and you can't really trust what it says. You can only kind of trust that OpenAI is, or whatever your LLM provider is, that it's doing a reasonable job.
So now that you have your LLM system in place, how do you make changes? How do you know when your product owner comes to you that, okay, we should reduce the number of times it apologizes? You make a change to a prompt. How do you know if that worked? You can test a couple of things, but with those couple of things, you know that those couple of things work this time. So it's really hard to understand what's going on with these systems. So that's why you need evaluations and robust evaluations. So you want to improve your developers' confidence before deployment, just like you do with testing. You want to make sure that you're not breaking things that already worked. And finally, if you do evaluation properly, you can iterate faster. You're not stuck in a loop of a developer on their own trying multiple different things and nothing really working, or not knowing what works and what doesn't.
Right, so you need evaluations, all right? So you need to have some sense of what your system is doing, and when you make a change, is it for the better, is it for the worse, is it improving some cases, making other cases worse? Like, you need this measurement, you need this evaluation in place. The other problem of evaluating LLMs, it is hard, because like the output of the LLM is just open-ended text, which we as humans can kind of look at and maybe like say like this is better or worse, but it's very hard to kind of have a label. So also like with visual data science, machine learning, you'd have labeled data, like this is a picture of a cat and this is a cat. This is a picture of a dog and this is a dog. So you'd have a label. Like with this open-ended text, you kind of have like a response, maybe from your assistant says like, I am sorry, like these things are not available right now in our inventory. Is that a good response? Maybe because they are being polite and they're apologizing, or it's a bad response because they actually were in inventory and they made it up, right? So all these kind of responses, just by looking at it, it's very hard to actually like write down good rules for what's a good and bad response. So because they're open-ended, they are hard to evaluate, and this problem has not like fully been solved. But if you like read all the blogs and all the Twitter and everything and see keep up with what everybody's doing, like these are kind of like the three main strategies that have emerged over this last 2 years, for at least trying to understand as best as we can, like is the quality of our system, of the responses, of the conversations improving over time or getting worse. The first one, very important, just human judgment. Just have people look at the outputs. So this is people, even the people who say they do this typically don't do this. So everybody says they're looking at their data. Most people are not. Most developers are not used to looking at like a happy path. So the problem is like, there's no error, right? Like you are sending the input to OpenAI, you're getting the response back, and you're forwarding it to your user. There's no error in the change. Like there's nothing in the log that seems there's a problem. But the answer was still not the thing that you should have responded to the user. And like for most developers, like as long as everything is like there's no errors, everything's fine. You have your test cases, but you're not used to looking at like let's see what the system responded to the user just for fun. Also, data scientists. We like looking at data, but we like looking at plots of data. So if you ask like a data scientist, like please have a look at the data, they got to make like some kind of plot with correlations and these kind of things. In this case, like you just need to look at the actual outputs. This is very important. Just look at your outputs a lot. The second part is heuristics and search. This is kind of like anything you can measure about your system. As you said, like it's hard to measure things, but there's still things you can measure. And the third one is using another LLM to evaluate the outputs of your LLM. So we'll be talking about this a bit later. But yeah, like as I said, like human judgment's always a good idea. Try to get everybody on your team to do this. All the developers, front end, back end, the UX people, the product owner. Everybody should be looking at the outputs. There's different way to organize this. We had like for one client, we had like every week on a Friday we'd have a session for half an hour where we'd go through this week's conversations, filtered by in different ways, and then and then at the end we would talk about what we saw. You can just make it, like everybody has to look at least like 100 conversations a week, or whatever rule you come up with, try to get people to look at it. One problem is this, that it does not scale really well. So if you get more and more users and more data, more and more conversations happening, you won't be able to look at every single conversation. Like when you just launch, you can look at everything. As soon as it scales, you don't have enough humans. If you're going to hire people somewhere else, you have to pay them. It's become very expensive. You have to instruct them. They don't follow the instructions because humans are also very hard to actually instruct and prompt. Another risk we've seen is like if you only rely on kind of humans looking at outputs and then developing based on that, you get this anecdote-driven development because you see like one bad response and this seems bad and this now becomes the focus for the next 3 cycles of iteration. So one senior executive has an issue with the assistant apologizing over and over when it shouldn't be, and now getting rid of these all these apologies becomes the most important thing. You put in the prompt like don't apologize, and then it becomes very rude instead, and you're kind of stuck in these things. So you want to know more broadly like which issues are actually important. So the human judgment is very important. You should always keep doing it, but you should augment it with other methods. So one of those methods is just think of anything you can measure around the output. So the outputs themselves are hard, like humans can look at them, LLMs can look at them, we can see in a bit. But often there are things like in your system that you can measure, such as, like most of these things, like if a chatbot has a thumbs up or thumbs down, those are very easy to track. But also like how long are the responses, like if it's a conversation, like how many turns in the conversation, recurring users, clicks, like all these kind of things that you can measure. Try to measure what you can measure such that you can see like suddenly one of these is going up or suddenly it's going down. Might not mean it's bad, like a long conversation can be long because it's really, really good and users are very, very engaged, or it's very bad because the user wants to get something done and the assistant is not able to fulfill the expectation, right? So and the user gets very frustrated and tries and it's not succeeding. So all these things are indication of maybe like a bad experience by the user, but doesn't have to be. But it's still something that you want to track if you can track it, and you can measure them. The third one is just using another LLM to look at LLMs, because the issues I said before was like the outputs are open-ended text. It's not like a clear label. What do you do with this? Humans can sort of interpret it, but other systems that are really good at dealing with open-ended text are LLMs. So this is the idea. So you simply use an LLM to evaluate the LLM output, and typically you use a bigger LLM. Like so, if your system in production uses like GPT 3.5, then you might use GPT 4 kind of evaluate the outputs. This we found actually can work reasonably well. It does scale, at a cost because you have to pay the inference cost, but it definitely requires some thought and alignment. So we'll go into more details about this. Another thing, like when we talk about evals, there's kind of like 2 different evals you have to think about. The first, offline evals, which is simple, like very similar to unit tests. You run like while you're developing, and before you release something. So before you release something, you want to know like, am I making things worse, or am I fixing the issue that I thought it was fixing? And am I confident that I can release this now to the users without all the examples I showed you in the beginning? The other kind of eval is the online eval, where you just want to know like what are the actual user conversations or the actual user interactions that are happening in the wild. Are they good? Are they bad? What are they talking about? What's happening? It is quite scary, like when you first launch and you don't have any online evals. And you don't have an easy way of actually observing that and no observability. So you launch a system, it's live, it's facing real customers, and you have no idea what's happening and if it's good or bad. So these are kind of like the 2 spheres of evals that we think about.
Yeah, so next I'm going to talk about the offline evals a little bit. And you can think of this as your normal unit tests or integration tests or whatever you're doing traditionally, except now, coming back to the talk this morning, this is flaky. Like everything is flaky. You're never going to get deterministic tests with this. So everything that we're doing in the offline evals is just to combat a little that flakiness. So what you want to do is you want to do quick experiments and immediately measure performance. So you want to spot issues before pushing into production, and you want to understand what kind of side effects your changes are going to have, because again, this also has side effects. So anytime you change your prompt or change anything basically in your LLM system, something else is going to change as well. So you want to understand what changes and are you comfortable with that. So here's a really quick example. The only point I want to make with this example, I'm going to talk you through very soon, but the point of this example is that this isn't like hard. What you can do is we have our test case here. We have input text for our test case. We're asking what's the best parrot. So let's say our system can do a couple of actions, and we want it to answer parakeet as the best parrot. So in the test case, you also have the labels that we expect it to do a search, and the search should return parakeet, and the final response should have the keyword parakeet. So our test case is just, did it use the correct action, and does the keyword match, in this case, the parakeet, and then you just call your LLM system, get your output, and that's it for one test case. But what you really want to do is have hundreds of these. So I'm going to spend a little bit of time on the heuristics part, just because they're really useful for offline evaluation. You can also do LLM as a judge for offline, but we'll cover that more in the online part. And the reason why heuristics are useful here is because they are reliable. You know that at least the test is deterministic, maybe not the LLM output, and they're really fast to run. You don't have to wait for an LLM API call also for your evaluation. So a couple of tips here. You want to use labeled data for expected patterns, like we had the parakeet and the search action. So here, if you can get your hands on some labeled data, do use that, and also make it yourself. You want to add reliability by evaluating a large set of test cases. So this is to handle the flakiness, because you can't get pass or fail. Like any given test can pass or fail regardless of what's happening. So you want to do a large set and then look at aggregate metrics. So my average accuracy for this test was 80%, so I'm happy. And just like with testing, you want to add new heuristics as you add new features or fix new bugs. And you want to run this as part of your CI/CD pipeline, mainly because you'll want to track these across time, like what changed across deployments, but also if unexpected changes happen. So for example, with OpenAI, they can decide to just change their model at some point. So you want to understand if something's changing. So then a few words about evaluation data. So your evaluation data, and I'm talking about data, not individual test cases, because individual test cases aren't enough. So the data should represent real usage, and it's really important to get this right, because over a couple of iterations, this is what your developers will pay more attention to, and kind of inadvertently, your system is going to do these things well instead of maybe some other things. Start small. You want to have something in place rather than nothing in place, but aim for as much as you can. You want to cover a lot of different patterns in your data, a lot of different ways of asking the same thing. You want them all to come up with relatively similar responses. And also you want to have good statistics. If you just have 10 test cases, your statistics could be all over the place. And to get that large data set, you should make it really easy to look at your actual usage logs and then come up with these test cases from those. This will make it realistic. You don't have to come up with the test cases. You can just like let your users tell you what they want to do with your system and test that. And then the other way that you can get more data is just use an LLM to generate. You can ask it to, like, here are some usage patterns. Give me more of these test cases similar to this. But make sure that they're realistic. So sometimes I've seen that doing this generation, the LLM just generates almost the same test case over and over again, or it just like makes up longer things when users are just using 2 words to ask your system. And again, continuously improve the data set. So everything here should continuously improve as you're going on. Nothing is like just one time and you can forget about it.
Cool. Yeah. So that's the offline. So that's all the stuff that you want to run before you deploy. But then after you deploy, your users are actually going to be interacting with your system. And it's actually like from one of the cases that Aili and I worked on was with a client that kind of had the first version ready to be deployed to the first beta users. Kind of got to that point. So by the time we joined, then it was like, oh, we can deploy this now, but we don't really know like what's going on. And soon we're going to have thousands. We're going to first roll out to hundreds, then thousands, and then like the whole population, millions maybe. So how do we know it's actually doing what we expect it to do? And as we saw with the example earlier with the car dealership, they probably tested it, before with a small demo to the owner of this car dealership. But see, you can ask it about like what's the latest model and how much horsepower does it have and how much does it cost, and like it answers, isn't this great? All right, put it live. And it didn't think about somebody would actually use this to start asking like, can you do it cheaper? Can you do it cheaper? Can you do it cheaper? Until it would go into $1, right? So it's hard to imagine before you launch how your user is going to use it, and this makes it extra vulnerable, which means also makes it more important to kind of keep an eye on what's going with real users. So real use is different from what you imagined beforehand, and different than you would think of yourself, like when you're testing this. So you need some kind of online evaluation where you're kind of evaluating how is this system being used in real life. Kind of for like three good reasons. One, just find interactions with issues. So any kind of response that's bad that you're not happy with, any kind of conversation that went off the rail. Like you want to be able to find those so you can fix them, and you want to be able to find them easily. The other point is like what Aili already mentioned. Like you want to use like the real live data to feed it back into your offline testing, to kind of really have that whole loop closed. And the other one is just monitor improvements, right? Or the other way around, like you can also get things getting worse. So if you have a release, then you want to see like does it actually improve the average quality or of the responses, and then this is an improvement or not, or is anything spiking or getting worse? So this is very important, so that you can also decide to roll back things. But in order to make a decision, you need to have observability in place. So you need to have some kind of online evaluation. Like the main tips we have, like for the most important one is just make it very easy to kind of visualize the outputs. So then there's like the different tools depending how complicated your thing is, how complicated the outputs. This might be very straightforward. It might not be. So in our case, like one of the clients we work with, like we had like one of the UX designers took a full week to evaluate 100 conversations. Because you had to get all the individual messages from the system as JSON, and then like copy paste them into Google Doc, and then find other search results, and then find the images of those, and like put everything together. It was a lot of work. So it was 100 conversations evaluated took a full week. largely because it was a lot of manual work to actually put this together. So here, I think it's very important to kind of invest some time either using existing tools or building your own. It's typically not that hard to kind of build your own thing for this, to make it really easy to kind of visualize and really go for all the different conversations or outputs very quickly, such that you can eyeball very quickly and look at these, right? So if it's important for humans to look at the outputs, you have to make it really easy for humans to look at your outputs. Otherwise, they will not do it if they have to copy-paste things from JSON. So then, so you want to find, ideally, you don't want to, especially if you have a lot of conversations, hopefully, you have a product that's very successful, a lot of users. So it's impossible to look at everything, hopefully. So now you need to filter, right? You can either do it randomly, but ideally you want to find either like the worst conversations or maybe the best conversation to show off to your senior stakeholders. So one easy way, obviously, is when you have some kind of user feedback, just filter by that. But the other way we found works quite well is this, using this LLM as a judge approach to kind of generate labels like, was it a good conversation or a bad conversation, what was good or bad about this conversation, so that you can filter by that, and then it becomes very easy to kind of find the conversations where a specific thing went wrong or that are very good or very bad, and this kind of helps you be really targeted in your eyeballing. So this LLM is a judge thing, so you use a larger LLM to look at your smaller LLM in a way. So this is one example, very basic, but I hope it gets the point. So you want your evals, this kind of LLM as a judge evaluation, to be in an output that is structured such that you can upload it to a database somewhere, right? Again, so you can have it in your front end and have filters and all these kind of things. So here we have an LLM eval of this conversation with an assistant. And one of the things we ask for is the quality, just on this rating of embarrassing, unhelpful, helpful, excellent. They should go with, along with some kind of a system prompt where you indicate what does this mean, what does it mean to be embarrassing, what does it mean to be excellent. But then if you show a conversation to an LLM and say rate this on this scale, it will do a decent job. You might have to tweak this, so you have to iterate a few times to see do you agree with the ratings, and then change the prompt or change the wording. But this is like a very easy way to kind of get to find those conversations which were particularly bad. Another thing we found worked really nicely is you can ask for a list of violations. So if you have a bunch of things that your assistant should not be doing, for example, that you have observed in the past. For example, the example we gave, if your assistant is always apologizing all the time, which also feels a bit off, then you want to find all conversations where it's apologizing. So then you can have a list of violations and have the LLM as a judge just add those as a tag to all the conversations where it sees kind of excessive apologizing, or here, wrong parrot, if your assistant start talking about a parakeet instead of a toucan or whatever, or it mentions a dog or a cat or something, you want to be able to track that. So for using this LLM as a judge, so one thing, you want to use this kind of structured output. I think there's a bunch of libraries that do this well, LangChain also does it now. I personally really Instructor is a library that's really good at going from these kind of models to the LLM output and then putting it back into a pedantic model. But there's other libraries that do this as well. This is really helpful. You get it in the right format. You can work with this easily, upload it to a database very easily. And also what you saw before, you can use LLM evals which are very generic, was it friendly or something, right? And you can use even LangChain has kind of built in. These are not helpful, I think. These are kind of, and people do this, evals, LLM as judge is kind of useless. I think if you make them very specific to your product requirement, actually work with your product owner and everybody else, what are the requirements, what should it be doing, what should it not be doing, and then you can actually put that into the LLM eval, right? So you should be really working with the product, and then it can be really informative. What are the things we want to keep track of that it should not be doing or should be doing, or any kind of Boolean flag for whatever it is. Then another thing that you may have noticed here, so I sneaked in, do I have a laser pointer here as well? Yeah, so I sneaked in a chain of thought here. So this is a way of kind of letting the LLM kind of reason first about the output. Is a conversation is, just list a bunch of good aspects, bad aspects of the system responses before answering the final label, like what's the quality. This both helps it to kind of reason towards like the right label, so like the accuracy goes up on the actual classification here, and it's also just a very useful summary to have. So if you're looking over all your conversations and you have all these summaries, maybe they're long conversations, but if you have like a short summary, it's very easy to kind of find the ones which are interesting to look at just by this summary. So this chain of thought is both useful to the model to kind of give better reasoned responses, and it's useful to humans that have to eyeball all these responses. And kind of the final thing, I found that people are initially quite resistant to using LLMs because they know they hallucinate and we can't really trust them. And like some people, like only humans, we can only have humans in the loop. Otherwise, we kind of have like LLMs judging itself, and people are often not super convinced about this. I would say just always just try it out. And understand the limitations. There will be hallucinations. It won't be perfectly aligned with what you would have, like what kind of label you would have put in every case. But like, don't let the perfect be the enemy of the good. You do not have enough eyeballs to have like an eyeball in every single conversation. Even then, like you won't be consistent among humans either. So this is like a nice way of having a scale, and you can, depending on how much you are willing to pay to OpenAI on inference costs, you can do this for all your outputs and have them all evaluated in a more or less consistent way. So I think this is very helpful. So if you have a chance to try this out, I would really recommend it.
Yeah. So after all that, looping back to the three things that we find online eval to be useful. So you can, of course, use your online evals as a way to find good cases for your offline evals. So once you've used your LLM as a judge or heuristics to find those problematic cases and also maybe like prioritize them, you can then look at them, understand them, and then loop them back into the offline evals. This makes it realistic, and then you're good to go. The third thing that you can do is just monitor and observe what's happening in your system at a scale. So one thing that we did in a project, we had these online evaluations, so we built a dashboard on top of that. And we were able to like look at the dashboard and okay, we made a deployment 2 days ago and all of these numbers went down. We wanted them to go down, so that's good. Or maybe some other things got up. Maybe we had some unintended consequences there. So finally, to bring this all into a system, you want to have evaluations in place at many places, at many stages of your LLM system. So you have the online evals between your users and your LLM system. You have some LLM outputs evals that are tightly coupled with each of your prompts. Then if you're doing retrieval augmented generation, RAGs, you want to evaluate those as well. And then if you're doing fine-tuning, there it comes almost naturally with the fine-tuning data, but you also want to have evaluations for those as well.
Cool. All right. So we want to just finish off with one like really awkward mixed metaphor. So you've probably heard the expression like data is the new oil. It was very popular like 8 years ago. So like in this LLM paradigm, you don't really need data anymore, right? Because you can just start and just call the LLM API. So then you could say like, actually evals then must be your new oil. But I think like you should really not underestimate it, because I think these evals, as we argued, like help you to move fast and iterate with confidence, right? And this is what will help you outcompete the other competitors, right? So with this kind of Gen AI products, everybody is calling the same APIs. Like you have a UX which can easily be copied. So what is going to allow you to outcompete other companies is being able to build faster and more quickly. And so anybody can have your UX and make a call to OpenAI as well. But if they don't have the same eval suite you have, they're not able to iterate quickly. So this is actually kind of your moat, I would say. So you can use this new oil to fill your moat and hopefully win whatever race you're in. And to make sure all those nice parrots can fly freely. All right, that's all we had. Thanks a lot.